Hey friends, welcome back to our YouTube channel Physics Zone. Today we are going to start a new chapter. It is center of mass and rotational motion. Okay, so till now we were considering a body like a single particle. Whenever we have to study about the motion, we always considered a body like a single particle. Okay, now if you will see around you any object, every object is made up of so many particles. Okay, now all these particles will have different velocities. When this object will move, when this object will move, all the particles contained in this object will move with different velocities and will move in different directions. Okay, during calculation we need single data, but now we have different data, so many data. Okay, now how we will manage this problem, how we will deal with this problem, of which particle we will consider to for calculation. So to deal with this type of problems, we are moving ahead to study about the center of mass. Okay, center of mass will solve our this problem. Okay, one most important term, rigid body, come across in this chapter. So what is rigid body? Rigid body, we have assumed a lot of particles in any object. When we will say this is a rigid body, so whenever any two particles in the body, the distance between the two particles remain fixed on applying force on it. That's called rigid body. Means the size and shape of the body is fixed and the distance between any two particles in the body remain fixed after applying force on it. Okay, this is rigid body. So now moving ahead in this chapter, we will learn about the different type of motion shown by any object. Okay, so now kinds of motion. We have three kinds of motion: translational motion, rotational motion, and combination of translational and rotational motion. Now we will study one by one. Okay, first is translational motion. What is translational motion? You have seen in linear motion, any object is if moving in a single direction in straight. Okay, then this is linear motion. This object is showing linear motion. Whenever any object is showing linear motion, then we say it is showing translational motion. Okay, now rotational motion. If any object is showing rotation like S, we have a body. This is a body. This is There are so many particles in this. Let's consider this particle is showing this motion. Okay. This is the axis around which this particle is rotating. Means this particle is showing a rotation around this axis. So here we will say this particle is showing rotational motion. Okay, some examples may be fan. Okay, any object that is rotating, motor, electric motor, these are showing rotational motion. Okay, third is combination of translational and rotational motion. Okay, now let's consider a wheel is moving downside from a slope. Okay, now when this is moving downside, it is showing translational motion, and this wheel is also moving like this, means it is also showing rotational motion. Means the when the wheel come from this side, it is showing translational motion, means from here it will reach here. It has covered some distance having a single direction. Okay, but this wheel is also moving like this, in it is also rotating, due to which it reaches here. Okay, so this wheel is also showing rotational motion, it is also showing translational motion. So this here we can say this wheel is showing combination of translational and rotational motion. Okay, when any vehicle move, its wheel also move ahead, and also they rotate. That time they are also showing combination of translational and rotational motion. Okay, now concept of center of mass. What is center of mass? Center of mass can be defined like as we have a body, it has so many particles, all the particles have their different masses. If the mass of whole body, means mass of all these particles, is considered at a single point, this point is called center of mass. Okay, the whole mass of the body is concentrated at a single point, that point is called center of mass. Okay, so now we will learn how we will find the center of mass of different bodies. We will start with two particle system. We have a system of two particles. This is the Cartesian plane. We have a system of two particles. If any body, we have considered these two particles in any body. Now we will find the center of mass due to these two particles. Okay, means there will be some mass of this particle and this particle, and the whole mass of this whole body will be considered at a single point, and where will be that single point? We will find that point. Okay, now let's consider this is the origin. Okay, this is the origin. This particle is at r1 distance from the origin, and this particle is also from some distance from the origin. Sorry. So now we have two particles m1 and m2. m1 is at point A, that is at a distance r1 from origin, and another point m2 is B at B, and it is at a distance r2 from the origin. Okay, now the center of mass of the two body system can be found like as. Now we will move ahead towards the center of mass. Let's consider m1 mass is moving with velocity v1, that is equal to dr1 upon dt. Okay, and m2 mass is moving with velocity v2, that is equal to dr2 upon dt. Okay, now F1 force is exerting on particle m1. Here an external force F1 is exerting on A, and F2 an external force is exerting on B. Okay, and these two masses also exerting some force on one another. Let's consider F12 is the force on m1 due to m2. Okay, and some another force F21 that is exerting on m2 due to m1. Okay, now according to the Newton's second law, rate of change of linear momentum of this particle is equal to total force acting on the particle. Okay, according to second law of motion, we know the rate of change of momentum of any particle is equal to the force exerted on it. So we know momentum is mv. So for m1 it will be m1 v1, and for second particle m2 it will be p2 equal to m2 v2. Okay, velocity is vector, so vector sign. Now the rate of change of linear momentum means dp1 upon dt. It will be equal to the total force exerting on particle m1. Okay, that is F1 plus the force exerted by m2 on m1 is F12. Okay, now for particle m2 we can say dp2 by dt. This is a change in momentum for particle m2. It will be equal to f2 plus f21. Okay, now we know momentum is conserved, so we can add by adding equation this one and equation 2, we get dp1 by dt plus dp2 by dt is equal to f1 plus f12 plus f2 plus f21. Okay, now we know the force that is exerted on A by m2 is in this direction. The force exerted on m2 due to m1 is in this direction. Means both of the forces are acting in opposite direction. Okay, so means and are equal. So f12 equal to minus f21. Okay, now f12 equal to f21. So both of these will be cancelled out because these are equal and opposite. Okay, so from here we get dp1 by dt plus dp2 by dt, that is equal to f1, this f1 plus this f2. Combined f1 and f2 can be written as f. Okay, now we can write is d by dt of p1 plus p2. Okay, that is equal to f. Now we know momentum is mv, means mass into velocity. So we can write momentum as mass into velocity plus so now we can write velocity as dr1 by dt. So d by dt m1 dr1 by dt plus m2 dr2 by dt. Okay, now d by dt, this can be written as d by dt m1 r1 vector plus m2 r2 vector. Okay, now this can be written as d square by dt square into m1 r1 plus m2 r2. is equal to F. Now we know from the Newton's second law, we know from Newton's second law, ma equal to F, means force is equal to change in momentum or mass into acceleration. So for making that formula, we can multiply and divide by m1 plus m2 to this equation. Okay, so we can write m1 plus m2 into d square by dt square into m1 r1 plus m2 r2. Okay, we have multiplied and divided to this equation by m1 plus m2. Now this m1 plus m2 also can be written here. m1 plus m2, after removing from here, we can remove this m1 from m1 plus m2 from here, and we have written it here. Okay, so now look at this equation. This is whole mass m, this is acceleration, and this is force. We know double derivative of any location is equal to acceleration. So this is the location. Okay, and this is called R. This m1 r1 plus m2 r2 upon m1 plus m2 is equal to R. Okay, sorry. This is the formula for center of mass. Okay, now this is the point where whole mass of the body is concentrated. This is called center of mass. If we have to find the center of mass of a two body system, then we will use this formula. Okay, now if we have given mass 2 kg, m1, m2 3 kg, r1 2 meter, r2 4 meter, then we can use this formula and we can find out the center of mass. Okay, so from here R will be equal to m1 into r1 plus m2 into r2 upon m1 plus m2. This will be equal to 2 to the 4 plus 4 to the 12 upon 2 3 5. This will be 16 upon 5. This will be the point of center of mass for a two-body system of masses and distances are given. Okay, so this was all about the center of mass of a two-body system. Further, we will also move towards a system where a lot of mass are contained in it, and we will also find center of mass for irregular or this type of bodies. Okay, so thank you for watching my video and have a nice day.